Do you know that data scientists add value to the organization by formulating business questions? For instance, what drives customer satisfaction? Or which products to prioritize for maximum revenue? Or how do marketing campaigns impact sales? These are basic business questions where data science can provide actionable insights and guide strategic decision-making. However, many early career data scientists make a common mistake. They focus so much on perfecting machine learning models, like accuracy, precision, and AUC, that they lose sight of the business problems they're supposed to solve. In today's data-driven world, delivering insightful analyses that are both well-explained and actionable is key for successful data science project. Effective analysis not only uncovers hidden patterns in raw data, but also serves as the foundation for building reliable machine learning models. Without a solid understanding of the business context, even the most sophisticated models can lead to missed opportunities and wasted resources because they fail to address real business issues, providing actionable results. In this video, I'll guide you through a three-step approach to turn your data science skills into powerful business tools. First, we'll define what constitutes a strong analysis tailored to specific business needs. Second, we'll develop actionable analysis plans that executives can implement. And third, we'll translate complex business problems into clear data science language. Stick around until the end for bonus tips on how to present your findings in a way that's engaging for non-technical audiences. So, let's get started. What does exactly analysis mean? Analysis involves a detailed examination and interpretation of data to extract insights and provide actionable recommendations. Typically presented through PowerPoint decks or Excel spreadsheets, analysis takes 1 to 4 weeks to complete, including data collection, statistical analysis, and conclusion. Examples include analyzing customer data for product satisfaction, examining geographical data for new factory locations, and using historical airline data to identify expansion cities. Unlike reporting, which focuses on presenting facts and metrics clearly and concisely, analysis involves a deeper dive into the data to understand and interpret it. Reporting simply communicates findings of what is happening, for example, KPI at specific time period, whereas analysis critically evaluates and synthesizes these findings along with why factors to draw conclusions or make recommendations. Therefore, analysis requires strong critical thinking. Good analysis itself has several characteristics such as: first, directly answers business questions. The analysis should address specific business queries, such as determining which website drives more sales, with clear results. Second, timely and shareable. Analysis should be completed within a month to ensure timely decision-making and should be presented in a way that is accessible to relevant stakeholders, featuring clear descriptions, well-written insights, and effective visualizations. Finally, reliable and accurate. Analyses should be revisited and updated regularly. This involves rerunning analyses with new data, adapting methods, and refining insights with communication update to stakeholders. To effectively address business questions, it's essential to develop an analysis plan. Take the question: why were wine sales low in Europe in December? Key contextual factors include: first, requester. Identify who is asking, manager, executive, or client, to tailor the analysis accordingly. Second, motives. Understand the goals, whether for strategic planning, operational improvements, or performance evaluation. For example, the wine sales are down by 10% this month and the business team does not know why it happens. Third, specific requests. Clarify what specifics are needed, like questions or metrics, to ensure business alignment. For example, the team wants to use data to see whether the wine sales dip was focused in one part of the country or bigger geographical regions. The metrics can be monthly sales by country or region along with historical comparison by month and years. Fourth, decision-making. Know how analysis results will shape decisions, strategic, operational, or policy adjustments, to prioritize findings appropriately. For example, the decision is whether the certain wine product should be discontinued. Finally, data availability. Ensure access to the necessary, complete, and accurate data for the analysis. If gaps exist, identify what data is needed and how to acquire it. For example, data required include sales order volume, revenue, market trends, and customer demographics. If you encounter gaps in information or data, communicate transparently with stakeholders. Explain why certain requests may not be feasible and discuss potential alternative data uses. Clarify why these alternatives might not fully meet the needs to avoid investing significant time in an unproductive analysis. By doing so, you not only avoid potential backlash, but also build trust and demonstrate professionalism as data scientists. If you are able to answer these questions, it is time to summarize a structured analysis plan that will establish the necessary connections. The analysis consists of three parts. First, descriptive analysis, that is helicopter point of view comparing December sales to previous month and same month last year's. It can be analysis of sales by country and region to identify general pattern. As an example, wine sales in Europe dropped by 10% in December compared to November and December sales that were 12% lower than the same month last year. Second, diagnostic analysis. Sales decline can be contributed to inventory levels, market price fluctuations, or certain customer characteristics by age group or gender or professions. For example, limited inventory could have contributed to the sudden drop in sales in Eastern Europe, or there was a price increase in Europe during December due to higher production costs. Finally, result interpretation and recommendation. Summarize the finding regarding the cause of sales decline and highlight any interesting finding or broader trends, along with actionable recommendations to improve sales. For example, improve inventory planning and management, particularly in regions experiencing stockouts. Or consider implementing promotional pricing or discounts in regions with significant price sensitivity, especially during high demand periods. After conducting a thorough data analysis connecting the relevant insights, the next step involves transforming business inquiries into specific data science questions. Following this analytical process, stakeholders would be interested in differentiating customers based on their purchasing behaviors, demographics, and sales patterns. Data scientists can utilize k-means clustering to effectively achieve this differentiation. Upon establishing distinct clusters that is well separated and compact, it is necessary to translate these findings back into actionable business strategies. The clustering process could reveal cluster A is filled with younger customers with lower incomes who tend to make frequent but small purchases, while cluster B represents customers who make infrequent yet substantial purchases and generally have higher incomes. Once customer segments are clearly defined, tailored actions can be applied accordingly. For example, increasing transactions can be devised by implementing budget-friendly promotional offers suitable to first cluster customers' financial capabilities while offering loyalty program for second cluster customers. By implementing these strategic initiatives derived from the cluster analysis, the data scientist contributes significant value to the company's objectives. All right, this is my promise. Data visualization is an important skill for data scientists when sharing data analysis and insights for non-technical audience where the plots must be well understood. The point is to help everyone agree what is really happening in the business as explained by data. Consider an example based on fictional data about pet names in a city. A data scientist wants to understand whether the letter a pet name starts with relates to the species of the pet, cat or dog. The data scientist loads up the data and makes this visualization, showing for each letter the split of cats and dogs whose names start with that letter. If you look closely, you'll notice that the T-bar has a much higher number of cats than dogs, a meaningful finding for the data scientist. That being said, this plot isn't something you'd want to show to a stakeholder. A lot is going on in the plot, and it isn't clear what the point is at first glance. An alternative figure shows the same data plotted in a different, more shareable way. In this version, it's clear that cats have a 12% chance of having a name that starts with letter T, whereas dogs have only a 5% chance. Now, this same data is something that could be shared. In summary, consider data scientists act as crime detectives, uncovering the reasons behind business phenomena. They analyze sales declines and provide actionable insights that inform decisions, adding value to the organization. Remember, executives prioritize solutions that improve revenue or streamline processes over technical aspects of data science like sophisticated machine learning models. Curious about how to elevate your data analysis skills to the level of top consultants at McKinsey or BCG? Stay tuned for my next video where I'll dive deep into expert techniques and strategies. Don't forget to subscribe to my channel so you never miss out on essential tips and insights about data science and analytics. Thanks for watching.